Hey everyone, let's dive right into this explainer and discover how math is honestly just like learning a new language. Fractions, decimals, rates, percents, they're literally just different ways of saying the exact same thing. If you've ever felt like math is just this random, confusing collection of numbers, well, you're in the right place today. We're going to completely crack the code of the grade 6 math curriculum on rates and percents together. We're building up a serious mathematical toolkit today, walking through 5 key areas. First up, the basics of rates. Second, converting measurements. Third, modeling with percents. Fourth, translating between fractions, decimals, and percents. And finally, solving percent proportions. By the end of this, you're going to be speaking the language of percents completely fluently. Let's get to it.
All right, section 1, the basics of rates. To kick things off, I really want to ground this abstract math right in our physical reality. Because math isn't just stuff on paper, right? It's happening inside you, right at this very second.
Seriously, try this. Take your first and second fingers, find your pulse, maybe on your wrist or on your neck, and just imagine silently counting the number of beats in 1 minute. Go ahead, I'll give you a quick second to think about what that feels like. Okay, so a typical resting heart rate might be something like 70 beats. But what exactly did you just measure? Boom, what you just experienced there is actually calculating a unit rate. Now, in math, a standard rate is just a ratio that compares two quantities with entirely different units of measure. Think heartbeats and minutes or miles and hours. But a unit rate? That is a special, super useful kind of rate where the denominator, the bottom number, is exactly 1. 1 minute, 1 hour, 1 gallon. So here's the crucial difference. While a standard rate compares two different units, finding that unit rate, like beats per 1 minute or dollars per 1 hour, makes it ridiculously easy to compare data. Like if someone earns $162 for 12 hours of work, that's a rate, sure. But if we divide that out to find they make $13.50 per 1 hour, now that's our unit rate, and it instantly tells us so much more about the actual value of their time. Moving right along to section 2, converting measurements. Let's take those unit rates and use them to translate measurements from one unit to another. Picture this. You're in a 6th grade science class. You and your team are building these cool model race cars, and you measure the distance your car travels from the starting line. Say your car travels exactly 14 feet. Well, how do we translate that into inches? You might kind of know the answer instinctively, but setting up the math gives us a totally foolproof tool we can use for way harder problems later. We can solve this real-world mystery by representing the conversion with a unit rate. We all know there are 12 inches in 1 foot, so we just multiply our 14 feet by the unit rate of 12 inches over 1 foot. By canceling out the matching feet units on the top and the bottom, we simply multiply 14 by 12 to discover our car traveled 168 inches. It feels like mathematical magic, but actually, it's just pure logic. And this brilliantly illustrates how we can scale up, say, a hot chocolate recipe for a massive party. If your recipe calls for 2.5 gallons of milk, but the grocery store only sells it in quarts, no problem. You just set up a proportion. Knowing the unit rate is 4 quarts per 1 gallon, you cancel out the gallons, multiply 2.5 by 4, and effortlessly translate that into the 10 quarts of milk you need to buy. Easy. Okay, section 3, modeling with percents. Now, fun fact, the word percent literally translates from Latin to mean for each 100 or per 100. And looking at a 10 by 10 grid is the absolute perfect visual anchor for this concept. A percent is always a part-to-whole ratio. On a grid that contains exactly 100 little squares, you can clearly see the whole is always 100. If 95 of those squares are shaded in, that is quite literally 95 per 100, or 95%. I really want to brand this number into your brain, 100. Whenever you are dealing with percents, 100 is your magic number. It's the universal whole that grounds absolutely everything we are going to do next. If you remember nothing else from this explainer, remember that percent means part over 100, which perfectly tees up section 4, fractions, decimals, percents. Because 100 is our universal whole, we can fluidly jump between these 3 main dialects of math. Honestly, they're just 3 different outfits for the exact same numerical value. Check out this equivalency. This is one of my absolute favorite math hacks. If you have a fraction with a denominator of 100, like 75 over 100, you can read it out loud using its proper formal math name, 75 hundredths. Say it with me in your head, 75 hundredths. That verbal cue gives you the exact decimal format, 0.75. And because it's out of 100, that directly translates to 75%. It is a seamless translation. So the trick to quickly translating a decimal into a percent is just multiplying by that magic number, 100. Or visually, if you want the ultimate shortcut, just swoop that decimal point exactly 2 places to the right. 0.85 becomes 85%. 0.70 becomes 70%. It's elegant, it's simple, and it's incredibly fast. And finally, the grand finale, Section 5, Solving Percent Proportions. This is the climax of our math toolbox right here. We're going to use everything we've learned so far to solve percent proportions when a critical piece of the puzzle is missing. This is where you officially become a mathematical detective. This formula is essentially your master decoder ring, the percent proportion. A percent over 100 equals the part over the whole. Remember, any two equivalent ratios make a proportion. So if you have any two of these numbers, the percent, the part, or the whole, you can set up this proportion and just use cross multiplication to solve for whatever unknown x you're looking for. Now, if the algebra feels a bit too abstract at first, visual models like tape diagrams are your best friend. Think of a strip of tape representing the total, or 100%. You just line up the part you have with its corresponding percent on the top, and then map the whole to our magic number, 100, on the bottom. It lets you literally see the relationship before you even start crunching the numbers. So your setup completely depends on what kind of mystery you're trying to solve. Sometimes you're hunting for the part, like if you know a shirt is made of 65% cotton and weighs a certain amount overall, how much of that weight is just the cotton? Other times you have the part and the percent, and you need to scale up to find the whole. The formula stays exactly the same. The location of your unknown x just moves around. Before you jump into any word problem, you've got to use this detective checklist. First, what clues are you given? Second, what is the unknown x? Are you solving for the part, the whole, or the percent? Set up your formula based on that. And third, and I cannot stress this enough, does your final number actually make sense in the real world? Like, if you calculate that a middle school math test had 5,000 questions on it, yeah, you might want to double-check your decimal placement. Let's test out that brand new toolkit with one final mystery. Trisha gets a 72% on her science test. We know she got exactly 18 problems correct. So that 18 is our part, 72 is our percent, meaning the unknown is the whole, the total number of questions on the test. How are you going to use the percent proportion to find that total? Set it up. 72 over 100 equals 18 over x. Solve that, and you've officially translated this math into real-world confidence. Thank you so much for joining me on this explainer, and happy calculating.